In the last video, we talked about the formation of the bony skeleton for prenatal bone growth. And remember that included endochondral ossification and intramembranous ossification. So the next couple slides are going to talk about endochondral ossification. When we hear ossification, it's helpful if you just think of that as bone growth. For endochondral ossification, it begins at the primary ossification center. So think of that as a primary growth center. There's a bone collar that forms around the diaphysis. Then the diaphysis elongates, the medullary cavity forms, and then the epiphyses are going to ossify. So you don't need to know every single step in this. Again, there's not going to be a diagram like this on the lecture exam. So what's important is that you can kind of compare and contrast the endochondral versus the intramembranous ossification. So endochondral ossification is going to start out as a hyaline cartilage model. So that's what we basically see in number 1 here. There is a bone collar that forms around the diaphysis. And again, it's the most common. It's much more common than intramembranous ossification. So this is going to be for long, short, and irregular bones. And from the last slide, we learned that it is basically the entire skeleton below the skull, with the exception of the clavicle. So this is an interesting one because it actually has 2 ossification centers. And that's another difference between the endochondral and the intramembranous ossification. So it's hyaline cartilage. We see the bone collar forming around it, the primary ossification center, which is a growth center. Then there's going to be a secondary ossification center, and that's going to be in the epiphyses. So remember, this is an epiphysis, this is an epiphysis, and of course, this is the diaphysis or the shaft. At the end of the long bones, there's going to be remaining hyaline cartilage at the ends of them, which is called articular cartilage. So again, as long as you know about 4 or 5 differences between the two. One recommendation I have is perhaps use a note card, put the 4 or 5 main characteristics of endochondral ossification on one side, and on the other side, put the main characteristics of intramembranous ossification, which is what we're going to look at next here. So intramembranous ossification begins within a fibrous connective tissue membrane. So that's definitely different than the endochondral, which begins as a cartilage model. This forms the flat bones of the skull, like the frontal, parietal, occipital, temporal bone, as well as the clavicle bone. It has 4 main steps to it, and those 4 main steps are kind of listed here. There's an ossification center formed, again, a growth center, and there's only 1 ossification center, whereas there was 2 for endochondral. The woven bone is formed when osteoid is laid down, resulting in trabeculae. And right away, that trabeculae should make you think of spongy bone. So these mesenchymal cells that are listed up here are stem cells, and the lamellar bone then replaces the woven bone. So again, just to remind you that when you see compact bone, you need to think lamellar bone. And when you see spongy bone, you need to think trabecular bone. So this image is showing the various steps of intramembranous ossification. Again, you don't need to know this diagram, all the steps in order, anything like that. But there is one ossification center here. So they develop in the tissue membrane. Those mesenchymal cells, those stem cells, differentiate into osteoblasts. Osteoid is secreted by those osteoblasts, and that calcifies in a few days. Then those osteoblasts are trapped in osteocytes, and that's where the canaliculi form that you can see right here. The immature bony cell and periosteum form. Then the last step is that compact bone replaces the immature spongy bone. So the trabecula are remodeled and replaced with compact bone. And then finally, there's a plate of compact bone at the end, sort of like a bone collar, which was the opposite of endochondral. So we've talked about all the prenatal bone growth. The next stage is postnatal bone growth, which is what occurs after we're born up until adulthood. So this mainly is going to apply to us getting taller. So the long bones are going to grow lengthwise in a longitudinal growth where they increase in diameter. And that's, in this case, it's called interstitial growth. When they increase in thickness, that's going to be the increase in diameter. The interstitial bone growth is longitudinal. So near the end of adolescence, those chondroblasts divide less often, and now the entire hyaline cartilage is replaced by bone. So epiphyseal plate closure occurs when the epiphysis and the diaphysis fuse. So it's a little younger for females and a little older for males. But when this happens, the epiphyseal plate or growth plate is now going to be transformed into an epiphyseal line or a growth line. I'll just put in parentheses growth. So what's interesting is you can actually see this on an x-ray here. So this is an x-ray image of the right knee, and they've blown it up here. So you can tell the difference between an epiphyseal plate and an epiphyseal line. So this is the epiphyseal plate that we see here. And there are 4 different zones. This would be the resting zone closest to the epiphysis, and the ossification zone would be closest to the diaphysis. So there's a growth zone where the cartilage undergoes mitosis. Those cartilage cells enlarge, called the hypertrophic zone. And then finally, new bone is formed at the ossification center. So when it's a growth line, we would not see any of these chondrocytes anymore. Everything would look like it's ossified. It would be complete bone. So when males reach 18, or I'm sorry, females reach 18 and males reach about 21.